Adjunct Professor Moran, Microeconomics 112, and we've begun a unit on comparative advantage. We're trying to explain why people specialize or countries specialize and produce what they're really good at, as measured by how much of another thing they don't produce, how much of that they lose. And they demonstrate the gains from trade that will result by specializing in trading as opposed to trying to make everything yourself. So graphically, I'm just going to try to give you a general idea of the difference between comparative and absolute advantage. So let's say there are two countries, and this is their production possibilities curve. So this would be, say, US, and this is cars and radios. And let's say this is Japan. So the United States is definitely better at making cars. We're further along the car axis, and Japan is definitely better at making radios. The United States has an absolute advantage in making cars compared to Japan, and Japan has an absolute advantage in terms of making radios compared to the United States. The United States is less able to make as many radios as Japan. But it is possible that a country is better at making both things. So let's say in this example, this is cars, and this is radios, and in this example, this is the US, and this is Japan. Okay. The United States has an absolute advantage in making both cars and radios. But if you can see, this is one way to determine it. You can see here that the United States is relatively better at making cars than radios, and Japan is relatively better at making radios than cars, based on the distance from the origin. This one relatively longer for the United States, shorter for the United States. Comparative advantage in making cars. By making cars, we lose the fewest number of radios. When Japan makes radios, they lose the fewest number of cars. Japan's going to specialize in radios. The United States is going to specialize in cars. So just because a country is better at making something doesn't mean that it's going to specialize in that thing. It's the United States here will specialize in cars because we're relatively better at making it. Japan's going to specialize in radios because they're relatively better at making that. And we're going to quantify that, but that just gives you a little insight in what we're trying to do here. So you're given the following information about a couple, and they have two chores to do. They need to vacuum rooms and wash dishes. Mike takes 60 minutes to vacuum a room, and he can do a load of dishes in 30 minutes. Debbie can vacuum a room in 45 minutes, and it takes her 45 minutes to wash a load of dishes. We need to figure out who's got what their opportunity costs are and who's got the comparative and absolute advantage. And to do that, we're going to use this table. All right, this is also posted online. These problems are filled with inverts, and so I suggest that you make all of these into fractions. Now, the first thing you have to decide is whether you have an input or output table. An input table has your resource in the table and in the numerator, and the output table will have what the good or service is as the numerator, the top part of a fraction. So here we have minutes. This is minutes per room, and minutes per room. Any number without a denominator has a denominator of 1, right? So minutes per room, okay. And then this is going to be wash a load of dishes. That's loads of dishes. That's minutes per loads of dishes. So that's minutes per load of dishes washed. So this is an input table. We're going to need to convert that to an output table. But the first step we're going to do is convert this to fractions. So 60 minutes is 1 hour. So I'm going to convert that to 1 hour per one room. 45 minutes as a fraction is 3/4. That means that it's 3 hours for 4 rooms. So I'm going to put that in the input part of this table, which is going to help us solve the problems. So that's 1 over 1 3/4. And again, that means that's hours per room, and this is hours per room. This is going to be Mike. This is going to be Debbie. This is going to be vacuum a room. And this is going to be wash a load of dishes. So now we're going to 30 minutes is 1/2 an hour. 45 minutes again is 3/4 of an hour. Now what does that mean in terms of an input table? An input table is input over output. Input is our resources, so that's hour per output dishes. So it takes Mike 1 hour to do 2 loads of dishes. If we convert this 3/4 of an hour into a fraction, an input-output table fraction, then what we have is hours per load of dishes, and you interpret that as 3 hours to do 4 loads of dishes. So we're going to put that in our table. It's 1 hour, 2 loads of dishes. This is going to be 3/4. This is 3 hours, and that's dishes. Alright, so now we're going to convert that to an output table. Notice I've written what this means. These numbers are input per output. That's time over whatever we're trying to produce, vacuumed rooms or loads of dishes. An output table is just the inverse, output per input. So all we have to do is take the inverse. Now we have rooms per hour and dishes per hour. So if it takes Mike 1 hour to do 1 room, as an output, Mike can do 1 room in 1 hour. Mike and Debbie. Debbie can do 4 rooms in 3 hours. I can do 2 loads of dishes in 1 hour. Debbie can do 4 loads of dishes in 3 hours. So now let's see who's definitely better at vacuuming rooms. It takes Mike can do 1 room in 1 hour. Debbie can do 4 rooms in 3 hours. 4/3 is larger than 1 over 1. She has an absolute advantage in vacuuming rooms. Let's look at loads of dishes. Mike can do 2 loads of dishes in 1 hour. Debbie can do 4 loads of dishes in 3 hours. Mike is better at washing dishes. Trade is not based on absolute advantage. Trade is going to be based on comparative advantage. So next we need to convert this to an opportunity cost table, which will give us the comparative advantage. To do this, we're going to make compound fractions. So we're going to draw giant division lines here. Now, an opportunity cost is what you give up divided by what you get. So if you choose to do one thing, that goes in the denominator. What you gave up to get that goes in the numerator. So if we let Mike vacuum dishes, we get 1 room per hour. So we put 1 over 1 in the denominator. If we let Mike vacuum rooms, we're not getting Mike doing 2 loads of dishes per hour. If we let Mike wash dishes, we get 2 over 1 dishes per hour. That goes in the denominator. But if Mike is doing dishes, he's not vacuuming rooms. So we're going to give that up. What you give up, divide what you get. Give up, get. The easiest way to remember this is just take whatever's in this box, put it in the denominator. Now, if Debbie vacuums rooms, we get 4/3 of a room vacuumed. But if Debbie's vacuuming rooms, we're not getting Debbie doing washes of dishes. So we're going to give up 4/3. Sadly, these numbers are coincidentally the same. If Debbie washes a load of dishes, then we get 4/3 dishes but then we don't get this 4/3 vacuuming rooms. Now we're going to solve our compound fractions. Solving a compound fraction means you invert the denominator and multiply. There are a lot of fractions on here. I'm going to circle our simplified fraction. This is 3/4. Invert this, multiply, 1/1. And this becomes 3/4 and 1/1. Okay. Now we're ready to determine who's going to be doing what chore. This was Mike doing vacuuming rooms. This is Mike vacuuming rooms. This is no longer Mike vacuuming rooms. This is if we let Mike vacuum a room, how many loads of dishes are we not going to get cleaned? This is Debbie vacuuming a room. Debbie vacuuming a room. But this is now, if Debbie vacuums a room, how many of the other thing, loads of dishes, are we not going to get? This is an opportunity cost table. What you give up divided by what you get. So these are what you lose if you let these people do this chore. So now we're ready to compare Mike and Debbie. If Mike vacuums rooms, we lose two loads of dishes. If we let Mike vacuum a room, we lose 2 loads of dishes. If we let Debbie vacuum a room, we're going to lose 1 load of dishes. It's better to only lose 1 load of dishes. If we compare it to 2, so Debbie's has a comparative advantage in vacuuming rooms because we lose the least amount of dishes washed. If we let Mike wash dishes, we lose 1/2 a vacuumed room. If we let Debbie wash dishes, this number is how many rooms she's not doing, 1. It's better to lose only 1/2 a vacuumed room than it is to lose a whole room. As a result of comparative advantage, Debbie is going to be vacuuming rooms and Mike is going to be washing dishes because we lose the least amount of the other thing. Let's look at how this looks. What's Mike's opportunity cost of vacuuming in terms of washing dishes? What's Mike's opportunity cost of vacuuming in terms of lost dishes? Dishes not washed, 2/1. What's Mike's opportunity cost of washing dishes? Look in the washing dishes row. And that number, although it's in the washing dishes row, represents how many rooms are not going to get vacuumed if Mike washes dishes. So this is 1/2. 1/2. What's Debbie's opportunity cost of vacuuming rooms? Vacuuming rooms, Debbie, although this is the vacuuming room row, this number now is how many loads of dishes not getting done if Debbie does the vacuuming. What's Debbie's opportunity cost of washing dishes? Look for the washing dishes row. Go over here. What's Debbie's opportunity cost of washing dishes in terms of vacuuming? So all this is in the washing dishes row. This is actually, if she washes dishes, how many rooms are not going to get cleaned? Vacuumed. Who has the absolute advantage in terms of vacuuming? Well, Debbie was better at vacuuming. She could do 4 rooms in 3 hours. Mike could only do 1 room in 1 hour. Debbie. Who has the opposite advantage in washing dishes? Mike can do 2 loads of dishes in an hour, but Debbie can only do 4 loads of dishes in 3 hours. 2/1 is larger than 4/3. So Mike has the comparative advantage there. He has the absolute advantage. Who has the comparative advantage in terms of vacuuming? Okay, this is vacuuming, the first row. Vacuuming, washing. Debbie has the comparative advantage in terms of vacuuming because we lose the least amount of dishes washed. We only lose 1/1, but if Mike does the vacuuming, we lose 2 loads of dishes per hour. So it's better if Debbie does the vacuuming because we lose the least amount of washed dishes. who has the comparative advantage in terms of washing dishes. If Mike washes dishes, that number, although it's in the washing row, now represents the opportunity cost of washing. That's how many rooms won't get vacuumed. If Mike washes dishes, we lose 1/2 of a room vacuumed. If Debbie washes dishes, we lose 1 room vacuumed. It's better to only lose 1/2 of a room vacuumed than it is to lose 1/1. So Mike has the comparative advantage in terms of washing dishes. In this example, it turned out that the person with the absolute advantage also had the comparative advantage for that. But that will not always be the case. And we're going to do a couple more problems to explore that. Okay, who should do each chore and why? Base rents only on the information above. Debbie should vacuum rooms because we lose the least amount of washed dishes. 1-to-1 versus 2-to-1. Mike should wash dishes because we lose the least amount of vacuumed rooms, 1/2 compared to 1/1. So we'll do another problem and continue to practice comparative advantage.